This problem is asking us to find the limit as x approaches infinity of our given equation here. Whenever someone's asking you about the limit as x approaches infinity, they're talking to you about the long-term behavior, but they're also asking you about the horizontal asymptote. So whenever we're talking about limits as x approaches infinity or x approaches negative infinity, that's the long-term behavior of our graph or the horizontal asymptote. They all mean the same thing. When doing a problem like this, I like to use what is just referred to as the leading behavior method. And what that means is you want to find the leading behavior on the top of your fraction and on the bottom of your fraction. The leading behavior, a better way of thinking about that is the dominant term. It's going to be the term that dominates how this graph behaves for very, very, very large values of x. And so when we look at this problem, I look just for the highest power of x. On the top, the highest power of x is going to be x cubed in that first term right there. On the bottom of the fraction, we're looking at x to the fourth. That's the highest power of x on the bottom of the fraction, so that's our leading behavior on the bottom. What that allows me to do is really just look at a simplified version of this problem. I look at this and I'd say, okay, well, this is 12x cubed over x to the fourth. What we're looking at in this situation is what I refer to as a bottom-heavy scenario. So we want to know where the dominant term is. Is it on the top of the fraction, the bottom of the fraction, or on the top and the bottom? Here, the dominant term is only on the bottom of the fraction, and so we refer to this as bottom-heavy. Bottom-heavy scenarios, what's really happening here is the bottom of this fraction now is getting huge. It's going off to infinity, and really there's nothing the top can do to stop it. So I think about that in terms of a 1. The top is not as dominant as the bottom, so it's not going to matter in the long term. When you think about that, that's 1 divided by a huge number, which is like a decimal point with a ton of zeros, right? And then a 1. And every time that number gets bigger, the zeros just keep adding on. And so what that tells us is the answer to every bottom-heavy situation, no matter how heavy or not heavy, the bottom wins out, and that means this thing is going to head to 0 always. So whenever you get a bottom-heavy situation, you know the answer in about 2 seconds, it's going to be 0. So your long-term behavior is that this graph is headed to a y value of 0. The answer to limit problems are always y values. It also tells us that our horizontal asymptote in a bottom-heavy situation is also always going to be 0. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.